Hello, viewers. In today's session, we are going to discuss a very important problem from functions. And in this session, we are going to discuss this problem in which we have to find out the values of x satisfying this inequality, that is cot inverse 3x square minus 5 greater than pi by 4. Now, this problem can be easily solved by the concept of strictly decreasing function, right? And once we know the concept of strictly decreasing function, then we can straight away find out all the values of x satisfying this inequality. So now let us first quickly see the concept of strictly decreasing function. Now consider a function y is equal to f of x, which is defined in some closed interval a comma b, right? And here since we are considering the strictly decreasing function, so let us roughly draw the graph of the decreasing function like this. And this is our function y is equal to f of x, and here we have the point A, and here we have the point B, right? So here y is equal to f of x is defined for all values of x belonging to this closed interval a comma b. Now let us consider 2 points x1 and x2 belonging to the open interval a comma b, such that x1 is less than x2. So here we can take this point as x1 and this point as x2, such that x1 is less than x2. So when x1 is less than x2, then this distance, that is the value of the function at x1, that is f of x1, is greater than the value of the function at this point x2, right? So when x1 is less than x2 and the function is strictly decreasing function, then f of x1 should be greater than f of x2. So now we can conclude that if we have a function y is equal to f of x, and if x1 is less than x2, implies that f of x1 is greater than f of x2 for all values of x1 and x2 belonging to the open interval a comma b, then the function y is equal to f of x is said to be that is strictly decreasing function. And the second definition of strictly decreasing function is that if we find out the derivative, that is dy over dx, which is f prime of x, and if f prime of x is negative, that is less than 0 for all values of x belonging to this interval a comma b, then the function is said to be strictly decreasing function. So if the derivative is less than 0 for all x belonging to the interval a comma b, then also the function is said to be strictly decreasing function. So now we'll take help of these two definitions to find out all the values of x satisfying this inequality. So now let us consider a function, say y is equal to f of x is equal to cot inverse x, right? And let us find out the derivative, that is f prime of x is equal to d by dx of cot inverse x. And we know that the derivative of cot inverse x is equal to minus 1 over 1 plus x square, right? And here we can see that 1 plus x square, 1 plus x square is always going to be positive for all values of x belonging to the domain of the function, that is f of x is equal to cot inverse x, right? And here we have the negative sign, so the denominator is always going to be positive, so this entire term should be less than 0 for all values of x belonging to the domain. So we can conclude that f prime of x is less than 0, right? So we can now say that the cot inverse x function is a strictly decreasing function for all values of x belonging to the domain. Now let us come to this inequality. So here we have cot inverse and we have 3x square minus 5 greater than pi by 4. Now pi by 4 can be replaced by cot inverse 1 because we know that cot pi by 4 is equal to 1. So we can write pi by 4 is equal to cot inverse 1. Right. Now let us closely look at this inequality, and in the both sides we have a cot inverse function, right? So let us take this input, that is 3x square minus 5, as x1. So we can take x1 is equal to 3x square minus 5, and let us take this input as x2. So we can take x2 is equal to 1. So now this inequality reads as cot inverse, and here 3x square minus 5 may be taken as x1, and here we have the greater than sign, then we have cot inverse x2, right? And see, here we have assumed the function f of x is equal to cot inverse x. Now f of x1 is given by cot inverse x1, and f of x2 can be written as cot inverse x2, right? So cot inverse x1 can be replaced by f of x1, and here cot inverse x2 can be replaced by f of x2, right? So for the inputs x1 and x2, that is 3x square minus 5 as x1 and 1 as x2, we have this inequality, that is f of x1 is greater than f of x2, right? So when f of x1 is greater than f of x2 and the function f of x cot inverse x is a strictly decreasing function, so by this definition we must have x1 less than x2, right? Because when x1 is less than x2, then f of x1 should be greater than f of x2 for a strictly decreasing function, and we have f of x1 greater than f of x2, and we have just proved that cot inverse x, that is f of x, is a strictly decreasing function because the derivative, that is f prime of x, is less than 0, right? So x1 must be less than x2, that is this input must be less than this input, that is 1. So now using this inequality, we can form the inequality in terms of x, taking x1 as 3x square minus 5 less than x2. X2 is 1, right? So we have 3x square less than 1 plus 5, taking minus 5 to the right hand side or adding 5 to both sides. So we have 3x square, here we have 6, dividing both sides by 3. We can now write x square less than 2, right? Now we can write x square less than the square of square root of 2. So now we have this inequality of this form, that is x square less than say a square, and we know that the solution of inequalities of this kind is given by x greater than minus a and less than a, right? So now here the value of a is square root of 2, so we can now write minus square root of 2. Here we have x and here we have positive square root of 2. So x lies between minus square root of 2 to positive square root of 2. So viewers, the solution of this inequality is given by this interval, that is x belonging to minus root 2 to positive root 2.